Today we'll be having Kirby Steckel talk about work that he did last summer, I believe, with Scope with Dr. Shram. So I'll turn it over to you.
All right. Hey guys, I'm Kirby Steckel, as Dr. Marr said, and I'll be going over my research in illuminating the space of beatable Lode Runner levels that are produced by various generative adversarial networks. So some of our motivation was previous work that showed that video game levels can be generated by GANs, and the structure of some games makes it really difficult for the GAN to actually produce beatable levels. And Lode Runner is difficult because there needs to be a clear path that is traversable to each gold, because the goal of the game is to collect all the gold to win. And if there are missing ladders, ropes, or ground tiles, then even simple levels can become unbeatable, even with just one missing tile. And I'll show you some examples of this later on. So some related works that we based our research off of was Generative Adversarial Networks generating levels for Mario, and then Doom down here in the bottom right corner, and then Mario Kart in the bottom middle, and then Dr. Shrum and Jake Gutierrez in 2020 published a paper on generative adversarial networks, graph grammars. So before we talk about generative adversarial networks, we need to talk about procedural content generation. So it's used commercially, and it's pretty much a way of algorithmically creating levels and rules for video games to save time and money during development. And an additional, another way of doing that is through machine learning, with procedural content generation via machine learning, which is still experimental and data-driven, where it learns the structure of the levels from the data that gets passed in as a training set. So GANs are capable of generating video game levels from learning the structure from the original levels, and they can generate very convincing fakes that are indistinguishable from real levels. So the first real breakthrough with GANs was this paper published in 2018 that generated a number of fake celebrity faces. So these pictures that you see over on the right none of those people are actually real. They're all generated by a generative adversarial network. So now a little background into Lode Runner. Lode Runner is a platform-based game that requires you to traverse ladders, ground, and ropes to collect all the gold. And you have to do all of this while avoiding enemies that have pretty much the same abilities that you do, besides being able to dig holes like the one that you just saw in the video. So to train again to generate Lode Runner levels, you have to start with the original level, which is in the top left, and then there's a repository called the Video Game Level Corpus, which has character-based representations of all of the 150 Lode Runner levels, and that's depicted in the middle. So each tile corresponds to a different character. So the black space in the level is the dot, and then the E is the enemy, and so on with every kind of tile. And then once we have the VGLC, we can easily transform that into a JSON, where all of those characters correspond to numbers between 1 and 8. Or 0 and 7. So then how the GAN trains is that it passes a latent vector of random noise into right here. in here, it goes through all the convolutions, and then it produces an output. So the discriminator over here takes that output, and as you can see, it's the output of the generator is the same size as the input of the discriminator. So the discriminator looks at that level, and it passes through all those convolutions, and it determines if the level is real or generated by the GAN. And while this is happening, the levels from the training set are also being passed into the GAN. So all of those are determined to be real. And then when you, ideally you finish training your GAN when the discriminator can no longer distinguish between the levels generated by the GAN and the levels from the training set. So we had a number of different training sets. We had 6 in total. The first training set was of the first 5 levels that are highlighted there. And the next one was the first 20 levels, and then the first 50, and then the first 100, first 150, and then the 6th one was actually a special one where all the levels that are in that training set have words or letters depicted in them. So all of those, so whenever I refer to the words present GAN, these are the levels that are in that training set, 13 in total. So we also used map-elites for the evolution, and map-elites is a quality diversity algorithm that searches the latent space for levels that are defined by the bin dimensions that I'll go over a little bit later. So then to determine if the level was beatable or not, we used an algorithm called the A* algorithm. And our model is very simplified. And the biggest challenge, or the first challenge that we encountered, was that digging in the game was very expensive. So to solve that, we just made it so that if there's a block on the right or the left, and the middle is a diggable tile that you can go down. And then another thing is that the enemies are not modeled because if you can traverse through the level, you should be able to avoid the enemies. And then also as well, our model was simplified so much that it made some of the levels from the original game not beatable, because it required the enemies to bring gold down to you, but since the enemies aren't modeled, it made those levels unbeatable. And for an example of the digging challenge, as you can see from my pointer down here, those blocks don't actually go away. They just, you're just allowed to pass through them because there are blocks on either side. So now I'll go over a little bit more detail of what the actual experiments that we ran were. So first off, the map-elites bins that I mentioned earlier were the percentage ground, the number of enemies, and the number of treasures. The fitness was measured by the maximum of the A* length and the connectivity. The connectivity is essentially just how much of the level you can traverse. And it ends up being a percentage between 0 and 1. And if a level is not beatable, it gets a A* length of -1. So the connectivity will always be higher than that. Additionally, all of these experiments were done using the average of 30 map-elites runs for each GAN. So now to go over a little bit of the results. So on 20 levels, generated the most beatable levels. It had the highest number of beatable levels in its bins, as you can see here. And then it also had the highest percentage of beatable levels. And then additionally, the words present GAN, although it performed poorly in producing beatable levels, it produced the largest variety of levels, as you can see by it being like almost twice as have twice as many as the others. So here is a heat map that maps the map leet bins that get filled. So the rectangles within the boxes are a single level generated by the GAN that get placed into a bin, and the color of those boxes indicates the length of the solution path. So dark purple means that the level was not beatable and that connectivity was used for fitness. And then lighter colors mean that the solution path length is longer and longer and that the level is beatable. So as you go through this chart, each column corresponds to a different GAN, and each row corresponds to one like range of percentages for ground. So for instance, this column right here is all those levels that are in those bins have 0 to 10% ground tiles. And then additionally, inside each box, there the levels that are higher to the top have more treasures, and the levels that are higher or farther to the right have more enemies, as you can see by these labels right here. And there's a little closer view. So as you can see, the on 20 levels and the on 50 levels have the most lighter colored boxes, which means they have higher solution, longer solution paths, which corresponds with the results that we saw in the plots earlier. Additionally, words present has filled most of its bins, but there are only a few instances where the levels are beatable, like down here. So to look at the levels more directly, we saw three main types of levels that got generated, like direct copies from levels from the game, merged levels where it took different elements from different levels and merged them together, and then chaotic levels where everything just seems like out of place and it doesn't really seem like there's any structure at all. So these two levels are almost exact copies from the game. There are a few differences over here on the right for this one, but the 150th level is pretty much this. And also this is nearly an exact copy to level 2, which we saw earlier on the right, on the A star slide, the one on the right. Next, we saw some merged levels. So as you can see for this level down bottom middle, it gets this, and that from this level right here, actually. And then this level gets this A and L from a level from one of the words presence level. And then this one gets the A from a different one. And then this one gets a D, A, J from a different one. And then additionally, here are here are some examples of chaotic levels. So as you can see, there's gold placed in places that like can never be found. See, like this place, you'd need a ladder to get up right there. This one's just floating in no man's land. And then there seems to be like this ladder, these ladders and ropes don't really do anything. It just seems kind of unstructured. And same with this one, like there's all this space here that only has like single ropes, which is going to be really hard to traverse as a player. And then this gold right here is unreachable because there's 2 little spots that are not filled in on the ladder. So to go over what I talked about earlier, if you want to generate diverse levels, you want to use the words present GAN. If you want to generate beatable levels, you want to use the on 20 levels GAN. On 100 and on 150 levels performed poorly in both respects, diversity and beatability. And this could be due to mode collapse, where essentially the generator gets stuck generating one type of level. And the ones that generated the most beatable on 20 levels and on 50 levels. So some future work. Some future work that we want to possibly extend the work that we did would be, instead of using the first X amount of levels from the original game, maybe doing random assortments of levels. So maybe, like, since the on 20 GAN performed the best, maybe just do 20 random levels instead of having just the first 20. That might come up with some interesting results. We could also try to find some more groups that have distinguishing qualities, like the words present GAN. And another thing is that to make the experiments more manageable and to save space, we put a search limit on the A star, but removing that search limit could reveal that some of the levels that were deemed as not beatable are now beatable. And additionally, a different binning scheme for map elites, as opposed to percent ground, number of enemies and number of treasures. Like, using a different binning scheme could find some new levels in the latent space. So finally, I want to thank the SCOPE program and the donors for offering me this opportunity, and Dr. Shrum for helping me with all of this. Does anyone have any questions?
Let's thank our speaker. That's great. Yeah, questions for Kirby?
So with the word GANs, did you ever think of, I don't know, some kind of other GAN that could maybe encourage, was it diversity, I believe?
I'm not
Or
sure if I
uniqueness?
understand what you're asking.
I don't know. Were there any other kind of GAN sets you considered using?
Not really. We kind of just chose this, like the 6 that we chose.
I think we considered some, but we just didn't have time.
Yeah.
I'm trying to remember. I don't remember what they were, but we had a list somewhere.
Yeah, it was a while back. Anybody else?
I posted a link in the chat so you can see a bunch of other levels that were generated.
Are you going to be like giving a talk during the Research and Creative Works Symposium?
Yep. At 1, right after our capstone ones.
Oh, no way. Okay, cool.
Yeah.
Yeah. That's awesome.
Hey, that means I'm going right after you, Kirby.
Oh, nice. I'll just stay in the call.
So Kirby, I may have missed it, but what did you consider any other games as possible contenders for this?
So actually, Ben over the same summer, Ben was doing work generating Mega Man levels. So it was being extended to another game simultaneously.
And you both started off doing some stuff in Mario and Zelda first, because like the Mario and Zelda stuff was already in there, and you two worked on that, and then you branched out into Lode Runner and Mega Man.
Mm-hmm.
I guess I am kind of curious about how like you know, like in Scope, right, or not Scope, but in your capstone now, right? You've done some work with Colt, like doing some like front end development.
Yeah.
And I know how that's like a wildly different paradigm, but I'm curious about like what your experience was during Scope and like how that translated to other coding that you've done after that. Like, did it make it easier?
It definitely it definitely made it easier. It made me more okay with not knowing what's going on, you know, like because when I first started Scope, I was like, okay, this one file has like 1,000 lines of code and I have to like add like do the same thing. What? But you know, I did it. Dr. Shrum helped me a lot. And yeah. And, like I didn't really know HTML and CSS that well before I started Capstone either. I kind of just figured it out as I went.
That's awesome.
Made me a lot more comfortable with that.
And you have another Scope lined up, Dr. Shrum?
Yeah, I mean, I do Scope pretty much every summer, and I already have 2 students chosen for this summer. They are not here today. They did go to, I think one of them was at Ben's talk, the homecoming talk that was on Tuesday. And so I don't know, we'll see. You know, maybe, but yeah, I mean, you're going to graduate, so you won't get to know them very well.
Yeah, well, I guess I'm curious if it's going to be more, or like, because now I've seen like 2 of your scopes, and they've been along this lines of like generating game levels. What is like, do your students like continue where the last ones left off, or?
It depends. Were you hanging out? Who else was in the lab with you that year that you were there?
It was Jake and Alex.
Alex. Okay, yeah. So, yeah, I mean, Jake did the paper with GANs, but everyone before that, I mean, Devin's here. I mean, everyone before that was doing like agent behavior, like evolved agents, and then if you go further back before that, Isabel evolved like animations, like interactive animation stuff, and it's unclear what we're going to do this summer. I mean, I think we might have someone evolving music.
That's cool.
But I don't know, and it's unclear if one person's going to do more GAN stuff, like what Kirby and Ben did, or do something more like evolving agents to play the games. We'll be flexible.
That's awesome. That's good to hear. It seems like it's going to be a fun time.
Yeah. If anyone ever has the opportunity to do Scope with Dr. Shrum, I highly recommend it. It's a great experience. Kirby, I had a question, actually. Yeah. So besides like making video games, are there other applications of using GANs to create like environments or terrain, or like how could this be applied to, you know, make environments maybe for other algorithms or like real world scenarios? I was wondering if you had any comments about that.
I'm not too sure, but I bet it could be applied to those. It would just be a matter of getting the right training data. Like getting if you got a training set of that information, then you could apply it. It's just a matter of how you want to represent that. Does that make sense?
Actually, Kirby, you mentioned in your presentation early on that the inspiration was generating human faces. And so I just wanted to sort of build off that. And I saw in an article when I first started Scope that some people in China are using GANs to generate faces for them to create and like use as a mask to prevent the human face recognition that builds you automatically. So it's pretty interesting.
I know that. I mean, you said outside of games, but there's like other things you can do with GANs, but they're still games. Like you can generate textures, like for like mapping onto a 3D model. You can generate textures. Also, if you want to have, like you're playing like an RPG and you want little like character portraits, like for your characters that talk, you can generate like fake faces of like, you know, NPC characters using a GAN. But this also gets used for like generating just like kind of like a generic kind of like customer service avatar like person, like basically there's companies now where you can say like, oh yeah, like generate like a fake person for me that I can like be, you know, have like as a representative, like a friendly face for like a chat program or something like that. So you can generate these fake faces, like it's like done commercially. So I know that that's one thing it's used for.
Yeah, no, more generally, like this topic came up at my company recently. One of my coworkers did a master's using GANs to create artificial data sets, so that if like you have a small data set, you can use a GAN just to create fake data and artificially make it larger for training machine learning models, which is really cool. I didn't think that's possible. Also, there is something at my company where they had doctors try and this like decipher which was like the real X-ray and which was like the GAN created X-ray, and like it's basically, you know, a crapshoot. They couldn't decide at all. So it's very convincing, like the images that can be created, and it's pretty exciting stuff. But yeah, awesome work, Kirby.
Thanks. Anyone else have any questions? Jake, did you have a question? You're just saying hi?
I found an example online of a system where you type in a text description of what you want it to draw a picture of, and it generates a picture of it, which is at least partially GAN based, which is crazy to me that that exists, but it's a lot of applications out there.
I do have one question though. What's the process, like the compute resource needed to be able to do that, like on the fly? Like an example of that, like are they doing that in the web browser, right? Like what you brought up, Dr.
Oh, you
Shum?
mean the thing that I brought up?
Yeah.
I mean, I don't know. I mean, if it does it, so training a GAN is expensive. Using it's not. It's like it's a single forward pass of a neural network is not that expensive.
Got it. So once you have like a refined product, so to speak, being able to like input, like just doing the input output is like not a big deal. You could have something like that in a browser without
Yeah,
like
I mean, it's
overwhelming
probably going
someone's
to
computer.
use JavaScript, you know, Node.js or something like that. I mean, there are libraries that hook this up so that it can use the right hardware optimization. And in some cases, it might even make it use your own machine, but you can do it server side as well. And like I say, it's like querying a neural network isn't that bad. It's training it that is really expensive, but even that can be done just slower.
Cool. Thank you.
Well, let's thank Kirby one more time officially.